All right, everybody, welcome. We are making the game of Asteroids today. Having a basic setup here for things like being able to press keys using the key press and key release functions to set some Boolean variables to true or false. So we can take a look at those to see what's going on with the keyboard. And otherwise, I haven't done too much here. So let's get started by making our spaceship that will be battling the asteroids in outer space. So I'll make a new tab, and I'm going to call this one the ship. This is going to represent a class that will be our spaceship that is flying through outer space. And we got ourselves, first of all, many things we need for a class. First off, we need instance variables. Second off, we need a constructor, or possibly more than one. And then we have behavior functions. These are the three things we're going to add in here. So to start with, the instance variables are just the information that any object of this class is going to keep track of. So for our spaceship, we're going to have things like its position on the screen, its speed, its direction it's facing, and how many lives it has left. So we'll put those things in. We'll put in a variable, keep track of lives. And then for location, that's usually we use the int xy or float xy. This time we are going to use a p-vector. And p-vectors are pretty awesome for all sorts of reasons, and I think you'll find that out today. We'll also use a p-vector to represent its velocity and its direction. And the reason why we have things separate from velocity and direction is we'd like to be able to turn our spaceship so that even if it's moving in a particular direction, we can make it face another direction. That's a hallmark of the game of Asteroids. So the constructor is where we're going to initialize all these instance variables. A constructor has a special way of naming it. Basically, it's like a function, except that instead of void, you just don't have a void there, and it has to have the same name as your class, but otherwise looks pretty much like a function. It has all the trappings of it. So that's going to be where we'll start here. So we'll start off set lives to 3, for example. We'll set our location. And the way we do that is by making a new p-vector object, and we can give it an x and y location. So I'm going to say p-vector, maybe width divided by 2, height divided by 2, which means that our spaceship's location will be half of the width and half the height, so the center of the screen. Its velocity, we'll also initialize it with creating a new p-vector. I imagine it's not going to be moving at all when we first start the game, so I'll just set it to 0, 0. And that makes a nice little owl face, is how I think of that. And then direction. So this will be a new p-vector. This will keep track of sort of what direction we're facing. Remember, the coordinate system is upside down in terms of the y-axis, so a negative y would indicate going up. So I'm going to make it point facing up. So I'm going to do 0, comma, negative 0.1. And the reason why it's negative 0.1 will become apparent later on, but basically I'm going to be using this as sort of my gas pedal. It's going to increase the speed, and if I make it too big, the spaceship will just rocket forward a little too much. I mean, spaceship should rocket forward, but we want it to be able to be controllable. But we'll get into that in a bit. The next behavior functions, we have void show and void act. So these are going to be our functions for making the spaceship do all the things it needs to do and to appear the way we want it to appear. So I guess what we'll do to make it appear is we will draw some kind of like a triangle-y thing, but we're going to be able to rotate this triangle, so we're going to need to use translate and rotate. The reason is because, well, first of all, we need to use translate if we want to use rotate, because rotate always rotates around the origin point, at around 0, 0. So that's not very good for rotating sort of a spaceship in its center of gravity. So we're going to have to translate to that center of gravity, and then we can rotate around that point. So in order to make that so it doesn't ruin the rest of our animation, that moving of the origin, we're going to surround all this stuff in a push matrix and a pop matrix. So this begins a temporary transformation, and this ends the temporary transformations. And again, that's just so that when we move the origin, we don't end up moving all the stars and asteroids and all that kind of stuff at the same time. So now we'll translate to location.x and location.y. That's how we're going to refer to the x and y components of a p vector. And did I spell that wrong? I did. I have an extra s in there. And then we'll also rotate, but we'll get into that in a bit. We'll just get this drawing happening. So, how to draw? I guess I'll draw the spaceship with a triangle. I'll probably put no fill, and then stroke white. I believe would be pretty classic. And then we would make a triangle. And I gotta make it around the origin, so a little bit around it. So I guess I'll do, I don't know, I'm gonna just estimate maybe negative 25 for the first coordinate, and 25. It's gonna be pretty small. That's okay. And then we'll do, that's one coordinate. The other one that's below it will be negative 25. Maybe I'll make that negative 25, negative 25. Negative 25, positive 25, and 25, 0. Does that make a triangle that's kind I want? Hey, no better way than to just try it out and see. We'll see if that triangle looks good. And then act is going to be making the spaceship's velocity apply to our location. So in order to move our spaceship, we can just do location.add velocity. And we'll add these two vectors together. Basically, our speed right now is 0, so we'll be adding 0 to our location. So that's not very exciting, but once we start accelerating and changing this, then every frame we'll be adding the velocities x and y components to our locations x and y components, which will make it move across the screen. Now, before we get any further, I'm getting a little confused. I'm like, oh, does that triangle look good or does it look terrible? I want to find out. So let's go and just leave our class alone for a minute, and let's go instantiate it and make it exist in our world. So I'm going to go to the main tab, and I'm going to, in our variables at the top, let's add ourselves in a ship variable. We'll make a ship called myShip, and then we will instantiate the ship. MyShip equals new ship. There's a constructor getting called. And then in the draw function, we can say ship.show and ship.act. So in other words, it's myShip. myShip.show and myShip.act. So that way we can, every frame, see the output of the show and act functions. So I'll run this and let's see how that triangle turned out. Yeah, okay. It's not bad. I could see a better triangle, because it's a little bit not obvious in terms of what is the front end of that. So maybe I'll just quickly make a little bit of a change. Let's, instead of these y coordinates, let's bring them down a bit. So it's a little skinnier. There we go. That's a little bit clearer, which is the front and which is the back, I guess. I don't know. Yeah, there we go. So I guess it looks pretty good. So now we're going to do a few things with these vectors. So first of all, a vector can be used for rotation. So we can tell a vector to give us like what angle is it pointing to. So after translate, I can say rotate. And I can say rotate to the direction. But it's not quite that simple because direction isn't an angle, it's a p vector. So I have to say direction dot heading. That will return the angle that the direction is facing at. And that's why we made it negative 0.1. That means it's pointing straight up. So that should be like a 90-degree angle pointing straight up. So let's see if that rotated us facing up. Yes, it did. We're pointing straight up. Okay, good. Things are coming along nicely. So let's add in some keyboard controls. So in terms of the act function, I would like to make it so that when I press my keys, I can rotate the spaceship, and I can like make it go, forward, like speed ahead. So we'll get that going on right now. So we can say things like if up key is being pressed, I'm going to make the up key sort of the gas pedal, if you will, the accelerator, the thrusters. So I will do velocity dot add direction. And then if down key is pressed, that's sort of the brakes, the reverse thrusters. So velocity dot sub direction. This is subtraction, of course. So we can either add or subtract our direction p vector onto our velocity to increase or decrease our velocity. So let's see, does that let us go forward? Yeah, it does. And I can go backwards and forwards. Because it continuously adds, I can get these nice gradual movements as if floating in space. Next, I'd like to be able to rotate. So I'll say if left key, then I can say direction dot rotate. And this is where p vectors become so nice, because I can just rotate a p vector without doing any trigonometry, and it'll just sort of understand. The only real danger here is that you have to use radians. Not everyone knows radians versus degrees, but we can use the radians function so that you can stick in degrees in here and it should be okay. So for example, I could rotate 5 degrees and then this will convert it to radians. So that's one way to do it. And I'm not sure if left or right is positive or negative, so let's just try it out and see if I get it wrong or right. Oh, I guess one of them should be negative. So it looks like this one should be negative. So now I can make myself kind of turn in different directions. And now if I hit the thrusters, because I'm adding the direction p vector to the velocity, now I can like go off in all sorts of different directions. That's pretty handy. Something that's famous for asteroids is when you go off the screen, you should be able to go around, wrap around to the other side of the screen. Right now I have it so that, that's not the case. So let's go change that. So it's pretty straightforward. All you need to do to have the wraparound effect is just examine if you've gone off the screen. And we need to not use just sort of 0 and width and height for those things because our spaceship has some size. So we'll give it a little bit of a buffer of a few pixels, maybe like 50 pixels or something. So that it goes off the screen a fair bit before we teleport it over to the other side of the screen. So we'll start off with if it goes off the top of the screen. So if location.y is less than, then we'll do 0. I'll do like negative 50. And even that might be not quite the right number. Then I'll teleport my spaceship by setting location.y to whatever the height of the screen is, plus 50. And I can do the same thing for if I go off the bottom of the screen. If it's greater than height plus 50, I'll wrap myself around to negative 50. So let's see if I can teleport now off the top of the screen. I go, and yeah, I have this sort of loop here where I go around and around. It doesn't work for the left and right of the screen, so we'll have to add that in there, but not too hard to do. Pressing space is strangely hard on a Mac. Frame processing, I don't know why. So we got location.x. Let's see if that goes off -50. Then we'll set location.x to width plus 50. And if location.x is greater than width plus 50, we'll wrap it the other way. Location.x equals -50. Alright, so we got our wrapping code going on now. So our Asteroids experience is looking pretty good. It's wrapping around the top and the bottom, and our ship is ready to go. Okay, so we're going to stop there for this video. So basically we made our ship using p-vectors. Our constructor initializes those things as well as lives. Our show function is all about showing it and using translate and rotate to make that happen. Our act function is all about reading in those keys so that we can apply these vectors to cause it to do its actions, like moving and wrapping around the screen. So that's that. Thank you very much.